Hi guys, welcome back to my channel. So from today onwards I'll be start teaching the low level design and I'll be covering from the basic till the advanced, starting from the solid principles and reaching to the level we will be covering all the design patterns that lie under the low level design. And it's very evident that nowadays in any of the interviews, even for the freshers, the interviewer don't hesitate in asking the questions of the low level design. So you can imagine how important low level design has become nowadays. So let's start. So today we'll be covering all the basics of the solid principles. So you can observe one thing, each and every alphabet of solid has its own significance. So covering from the first one, S. S means single responsibility principles. Let's see what single responsibility principle tells us. Okay, so it tells us a class should have only one reason to change. It means that whenever we are creating a class, we make sure that all the methods that should be created inside the class should be related to that class only. Okay, why I'm saying this? Let's see the example. So here is the best example which is explaining the single responsibility principles. So you all can see here I have created three classes: user service class, email class, or logger class. Okay, so instead of creating the three classes, I would have created one class which is the common service, and I would have implemented the create user method, okay, send email method and log method inside this single class. Okay, but it will violate the single responsibility principles. Why? Because let's say this create user is handling the concept related to the user, this send email handling the concept related to the email service, this handling the concept related to the logger service. Now if in future if I want to change the method logging, so I need to touch this class. Okay, but what single responsibility principle tells us is a class should have only one reason to change. It means that if in future if I want to change the method related to email, then also I need to touch this class. In future if I want to change the method related to logger, then also I need to change something in this class. So it will violate the single responsibility principle. So instead of that, what I have done is I have created a user service, I have created the email service, I have created the logger service with all the details method or related methods inside that class. Now let's see what I have done here. What I have done here is I have created an email service, an object of that email service, an object of that logger service, and I have leveraged the use of instance variables by creating the instance variables or fields inside the user service. Okay, what I'm doing here is I have created an object of user service and passing the object of email service and logger service inside the user service as an parameterized constructor. Okay, what it will do, it will initialize the values of objects. Okay, now next thing what I'm doing here is email user service dot create user. I'm providing the name and also I'm providing the email. What it will do, create user, name and email. What it will do, it will just simply print the name of the user which I am creating. Now with the help of email service, what I am doing, sending the email, okay, in the same class user service. Okay, in future if I want to change anything regarding the send email, I will change the send email which is in the email service class, not in the user service. Now in future if I want to change anything related to log, I'll be changing the log service method, not in the user service. So this is how I have achieved this single responsibility principle. Okay, so through logger service what I'm doing, user printing the name was created successfully. Through send email what I'm doing, printing the email and welcome the name which I'm providing. Let's run this class, run as Java. So you can see here we have printed the name of the user. With the help of email service we have sent the email to the user, and with the help of logger service we have logged that alias was created successfully. Now one more thing, just out of curiosity, I am say just another way. One to I have used through parameterized constructor passing the object of different service. One thing I can do here is I am just using the default constructor and creating the object here itself. If I comment out here and I'm uncommenting this also works fine. Why? because this user service will create the new object of email service and logger service here, and after initializing the email service and logger service, I'm leveraging the use of this instance variables by assigning and calling the methods respectively. So if I run this Java, then it will also run fine. Okay, user created allies, sending email to this email with message welcome allies, and logging the user allies was successfully created. So I hope the single responsibility principle is clear to you all. So one more thing, violation of single responsibility principle. What is the disadvantages or what is the repercussion that we will be facing if we violate SRP is every unrelated changes means if any change which is not related to that class touches the same file, then there is a risk of regression increases, means that whatever methods we are writing inside that particular class, just because of some other changes which can be separated, but instead of that we have put inside the same class, if we are changing in that same file, we need to again perform the regression. Okay, testing gets harder. It means that every time we are changing in some particular class and we need to test the complete class methods. Okay, and maintenance cost skyrockets. It means that it is very hard to maintain the classes. Okay, so now we will be moving to next principles. So hi guys, now next we'll be looking into the second abbreviation of the solid principle, which is nothing but open close principle, because we have seen that SOLID. S I have already covered. Now it's time to cover O. Okay, so this is open close principle. What this definition is, a class should be open for extension, okay, but closed for modification. Means in an existing class it should be closed for modification, means we should not change an existing class, but we can extend it whenever new features come. This is the overall idea of this open close principle. Now let's see what it actually means. You should not modify an existing tested and deployed class whenever new requirements come. Okay, instead you can extend it. Okay, instead whatever class or interface we'll be using, we should extend it and append our new functionality. Okay, or define our new functionality. So usually we extend it via inheritance, composition and interfaces. I'm pretty sure that you must have heard this term interfaces, inheritance, but this composition term must be new. So I'll be explaining it with the code to add the new behavior. Okay, now our main idea is to make our design flexible and stable. Why stable? Because old and tested code remains untouched, and flexible because our new functionality can be plugged in very easily. Okay, now before moving into the code or open close principle example, we must be confident about whether to go for abstract classes or interface, or what is the differences between abstract and interfaces and where to use what. So let's see. So let's start with the abstract class. It provides a common base for closely related classes sharing a common state. Okay. On the other hand, interfaces defines a contract that classes must adhere to, specifying a set of methods our class must implement. Okay. Now let's move to the second point, which is very important. This is the point I'll be explaining with the code. This, and from the interface side, this point. Okay. So abstract class can have abstract. Abstract means unimplemented methods, and concrete means implemented methods. I'll be explaining this. Now on the other hand, in the interface side, it could only have abstract methods. What do you mean by abstract methods? Abstract methods is the methods in which there is no implementation. It is just a contract, or we can say that it is a blueprint which forces these subclasses to provide the specific implementation of that method. Okay. Now after Java 8, interfaces can also have default and static methods. I'll be explaining this, okay, with implementation. Now moving to the third point, which is nothing but abstract class can have constructors, but interfaces cannot have constructors. Okay. Moving to the fourth point, methods and fields can have any access modifier like private, public, protected and private in the case of abstract classes. But in the case of interfaces, all members are implicitly public. Okay. Now last but not the least, a class can have only one abstract class. Means whenever there is a class, it can have only one abstract class. Okay. But on the other hand, in the interface side, a class can implement multiple interfaces. There is a class that can implement multiple interfaces. Okay. You all must know that in the Java, we cannot implement the multiple interface directly, but through the interface it can be possible. Okay, now let's move to the code. So here is the code example of interface. Okay, first we'll be looking this point in case of interface. So interface can have abstract methods, but after Java 8 can have default and static methods with implementation. Let's see here. So I have declared an interface called drawable. Okay, I have declared an abstract method which is nothing but draw. It's still an abstract class. Okay, a method which is of type int, it is also an abstract method. Okay, now we'll be seeing that after Java 8 can have default and static methods with implementation, so interfaces can have default methods also. So this is the default method void resize int factor. Now one thing, if this is the case, in this case the default keyword is missing, so we cannot provide the implementation of this method. But whenever we put the default keyword with the method, we can provide the default implementation of this method. Okay, so this is the instance method with implementation, which is nothing but the default methods. Now coming to the static methods. So what is static methods? Static methods is not dependent on the instant of the class. Okay, it can be called directly with the class. So we'll see that this is a static method which returns nothing but an interface drawable. Okay, so the return type is drawable itself, and the method name is create default drawable. Okay, so the method return type is drawable. So we can see here it is returning a new drawable object. Okay, in which if we are creating a drawable, so we need to override draw and get line thickness, because it is an interface, and we have seen here that it defines a contract that classes must adhere to, means whatever class. So whenever we create an object, we need to override this draw and this get line thickness. For this case, resize is optional. Why? Because if we'll not mention the resize, if we'll not provide the implementation of a resize, then it will take the default method of the resize. Okay, so this is mandatory and this is mandatory, this is optional. Okay, so if I'll remove this, if you'll see, there is an error. Okay, that means it is showing that you need to implement the abstract methods which is implemented inside the interface. So I'll be doing this. Okay, so now after that I have created one static methods. I have created another static method which is print info. The main motto of creating a static method is to show that we can directly call the static methods with the help of drawable. There is no object needed to call this static methods. Okay, so I have created two static methods, in which in the first static methods I am returning the drawable itself, interface itself. If I am returning the type drawable, then I need to override this draw and I need to override this method, because this is the abstract methods and this is optional. Okay, in the case of second static methods, I have provided the implementation that this is a print info static methods inside the drawable interface. Okay, so now let's see by running the code. Okay, I'll go up. This is our main method. So what I'll do here, I'll comment out this because this is the example of open close principle that I'll be explaining. So this is our main open close principle example. Inside that I have done some I have written some code. So default, to show the default and static methods in interfaces. So we can see here that drawable is equals to drawable dot create default drawable. Okay, so create default drawable is returning a type of drawable. So we are storing draw in the drawable interface. Okay, so what it will give, now we'll run this. Okay, so the first thing, overwritten draw inside static method. Why this comes? Because whenever we have called this create default drawable using the class name or the interface name, it returns the object here. Okay, it returns our type here, and with the help of drawable we are calling few methods. Okay, you can see here inside drawable this has given drawable object. Okay, now we are calling draw, get line thickness and resize. So you can see the output here. Overwritten draw inside static method means this part is called. Overwritten resize inside static method. Overwritten resize inside static method, which is factor. What we have provided here, we must have provided 5, so it has printed 5. Okay, and last and also get line thickness. Okay, get line thickness, nowhere we are printing, we should print this. Okay, what we'll be doing, line thickness. Now we should run this. If I'll run this, it will print line thickness, which is nothing but we are returning 1. That's why it is printing 1. Resizing we are providing 5. That's why static method it is giving 5. Now another thing, the one static method we have called using the drawable class, the another static method we are calling using the drawable class, and because the type of this print info is void, we are not storing anything. We are just directly calling this and we are getting the output that this is the print info static method inside the drawable interface. I want to show you one thing, that if I'll remove the overridden method and will call the resize, then what it will print. Okay, here overridden size inside static method it is printing. Now it should print default resizing. Okay, let's run this. It is printing default resizing 5. So I hope this is clear. So I'll repeat or I'll conclude one thing, that inside the drawable interface we can create the abstract methods, which is nothing but these two methods. Okay, as I have told you, we can create the abstract methods. Okay, now moreover we can create the default method with the implementation, which is possible after Java 8, can have default and static methods with implementation, and also the static methods with implementation. And the main motto of static method is to, like, we can directly call the static methods with the class name. There is no object needed to call this method. Okay, these are the static methods. So these two static methods I have created. Now I hope this is clear. So just refer to this, you will be very clear, like whether to go for abstract classes or interface I have covered. Now we'll be moving to abstract classes. So now before moving to abstract classes, let's see the points which I have written. So interface allow you to add a new method to an interface without breaking existing classes that implement it. Okay, means let's say somebody is already implementing an interface, so we can add a new functionality here without breaking the existing classes. Okay, this is the main and important crux of open close principle. Okay, if a class doesn't override the default method, it simply inherits the default implementation. Just like here, if the class doesn't override the default method, it will by default get this implementation of this default method. Okay, next point is classes implementing the interfaces automatically get the default implementation. That is clear. Classes can optionally override the default implementation. This is optional. I have repeated multiple times that this method, which is default, is optional for any subclass which is implementing this. Now if you add resize as a default method, existing class implementing drawable don't need to change. Okay, they automatically inherit the resize. Okay, now let's say somebody is implementing this drawable, they will automatically get this default method, but if they willingly want to change the implementation, they can do it. Okay, new classes can either use the default or provide their own resize implementation. That what it is actually trying to say. Okay, I hope this interface with the default and static methods are clear, and I hope when I'll be giving an example of open close principles, you will be very clear like why I have considered the interface there. Okay, so this is the part of default method. Now we'll be moving to static methods. Some important points. So these are static methods defined in an interface that also have an implementation. As I have shown you, like these static methods have an implementation. Another static method, it also have an implementation. Okay, the methods are directly related to the interface but don't require an instance of the implementing class. Means let's say some class is implementing that interface, that doesn't mean that if a method is declared as an static, then it does not require the object of the class to call that method. Okay, just repeat it one more time. They can be called directly on an interface itself. Okay, now moving to the third point, they are called by the interface name that I have shown above, that we are able to directly call this method using the drawable interface. Okay, they cannot be overridden by implementing classes. Like static methods cannot be overridden. Okay, let's say some XYZ class is implementing this drawable, then they can override this draw, they can override this get line thickness, they can override this resize, although it is optional, but they can never override the static method. Okay, I hope this is clear. Okay, so now let's move to the abstract class and unimplemented method. So now we'll be looking into the second point of this abstract class, which is abstract unimplemented and concrete implemented method. Now we can see here, so what I have done here is I've created an abstract class of vehicle in which it is an instance variable which I have used. Okay, this is the constructor which I have declared, in which I am setting the brand. Okay, this is a concrete implemented method. I have declared an implemented method, means all vehicle must start engine. This is vehicle started. Okay, this is a generic way to do it, means it is an implemented method. Same implemented method, the return type is different, it is a brand. Okay, now this is the abstract unimplemented method. as I've told you in this point, abstract class can have abstract and concrete, which is nothing but implemented method. Abstract is unimplemented and concrete is implemented. Okay, so this is the unimplemented method, which is the abstract method. The same abstract method, unimplemented method. This is the concrete methods. Implementation is there. Okay, now we'll run this. Okay, before running, we'll see that car is extending this vehicle. I have explained you in this point that a class can have only one abstract class. A class can have only one abstract class. Okay, now this car, we have provided the string brand. Okay, super brand means it will be setting the super class brand. Okay, with the help of this constructor. Now tell me one thing, by this point of time what you'll understand, that if any class is extending this vehicle, what are the methods that they need to override. Okay, so you are correct that the move and the stop. Okay, so move and stop, they need to override. This is optional. If I'll remove this, I'll get no error. If you'll see, there is no error. Why? Because the implementation of, I guess, start engine is already there. Okay, but what if I'll remove this stop? If I'll remove this stop, you all get this error. The type car must implement the inherited abstract methods vehicle.stop. Okay, this should be implemented. So I guess you are very clear that all the abstract methods that is declared inside the abstract class must be implemented by the subclass. Okay, this is the point, very important point. So I hope this is clear that abstract class can have implemented and unimplemented method. Now we'll run this. What I'll do, I'll comment this part and I'll run the abstract. If I'll run this, what is the expected behavior? Okay, so what I'm calling here is car.startEngine and getBrand. Okay, we'll see here car.startEngine. Okay, so car.startEngine, it is providing the overridden. Okay, so Tesla overridden vehicle engine started. Okay, then Tesla car is moving on the road. Tesla car is moving on the road, which is move and stop. I have called start engine, move, stop. One more method I have called, which is nothing but get brand. I need to print this here because it is a type of string. So now if I'll run this, you'll get Tesla overridden, which is nothing but start engine. Okay, this is the brand that I'm printing. This is the brand that I'm printing. Tesla car is moving on the road. This is move and this is stop. Okay, now I'll show you one thing, that if I'll remove this overridden method start engine, then what it will pick? It will pick the default method, like whatever the implemented method that is there in the super class. If I'll run this, it will give vehicle engine started, Tesla vehicle engine started. Okay, start engine here also. Okay, here I have written overridden. So I hope this is clear. Now let's move to some point of abstract method. Now some important point of implemented methods and unimplemented methods. Now these implemented methods, so these are the methods within the abstract class that have a complete body. Complete body means these have the implementation with them. Okay, coming to second point, which is classes can inherit these concrete methods and can use them as is. Like the classes, in this case it is car, can inherit this method and use as is, or they can choose to override them if they need to provide the different implementation. This part I am saying they can, because car has the choice that they can use the default method, this one, but they have selected the way they want to override and provide their own implementation. Okay, this is optional. Now purpose is to provide a common functionality that many or all classes will need without requiring each subclass to rewrite that common code. Let's say I have written the common code that vehicle engine started, but somebody wants to change it on their own, then they can override and change it. But again, I'm saying this is optional. Now moving to unimplemented methods. These are methods declared in the abstract class but do not have a method body. They are marked with the abstract keyword. Okay, you can see here what I have declared, public abstract. Okay, now an abstract method acts as a placeholder or a contract. It declares that any concrete subclass, let's say in this case it is car must provide its own implementation for this method, like move and stop. They need to provide the implementation. Okay, if a subclass doesn't implement all inherit abstract methods, it must also be declared abstract. This is very important. I'll show you. If let's say I don't want to implement the move method, okay, this will give error. But what if I'll declare the class itself as an abstract, then the error gone. This line is saying the same thing. So if a subclass, in this case it is car, if it doesn't implement all inherited abstract methods, in this case it is not implementing the move, which is an abstract method, then the class itself should be declared as an abstract. Okay, then the class car itself should be declared as an abstract. Okay, I hope this is clear. Now I'll remove this. Now I hope this is clear. So second point is also clear. Now coming to the third point, it's about defining a common common interface of behavior that all subclasses must support by allowing each subclass to implement it on its own unique way. This is the main motto of unimplemented method. Okay, now let's move to the next important thing, which is just like the things which you can keep in mind while declaring abstract classes, interfaces and all. So whenever you see the interface, just remember that what to do. Okay, no real code is just a promise that I will give an implementation of this method. Abstract class means common stuff, like it is common for all the classes, but there are some special stuff also. Okay, special stuff means some code are shared, some needs subclass to finish. Okay, let's say in abstract classes there are abstract methods which need subclasses to finish, but there are some code which has implemented, which is already implemented, so the subclass can use it. Okay, now the class is like complete and ready, like everything it is implemented inside the class. Now let's move to some rules while extending and implementing a class or interface, which is also very important because many new folks gets confused, like what are the rules when we extend a class or like implement an interface, or like what are the rules. So rule 1, if a class implements an interface, it must implement all the interface methods. Okay, I repeat it, if a class is implementing an interface, it must implement all interface methods. Okay, because an interface is a contract. If you say implements, you are promising that I will provide the code of every method. Okay, in this case, let's say interface flyable, I have created 2 methods. Now if a bird implements flyable, then the bird must give an implementation of this fly or land inside this body. Okay, if bird misses even one method, then it will show the compiler error that I have shown you while I was explaining the interface. Okay, the only exception is the class can avoid implementing methods if it declares itself as an abstract. Like if you don't want to give an implementation of fly and land, you must need to declare this class as an abstract by mentioning this abstract keyword. Okay, so now so I have given this example, abstract class bird implemented fly. No need to implement fly or land. Okay, now the one who extend bird need to give implementation of fly and land. Okay, so I hope this is clear. Now coming to rule 2, which is if a class extends an abstract class, there are 2 choices. Okay, repeating, if a class is extending an abstract class, there are 2 choices. An abstract class may contain abstract methods. Okay, so the child has exactly 2 options: implement all the abstract methods. Okay, just like this, like the vehicle has this move. So if a class is extending an abstract class, it must be implemented. Or option B is do not implement them, but then the child must also be an abstract. This is the 3rd time which I'm repeating, that if the subclass do not want to implement the methods, then the subclass should also be declared as an abstract. If it's not an abstract and it doesn't implement, there is a compiler error. Okay, I hope this is clear. Now rules to implement or extend. Okay, so rule 1, class extends class. Extend keywords is going with class. Single inheritance. Okay, class implements interface. Okay, any number of times. Class can implement multiple interfaces. Okay, but here class can extend only one class. This is the single inheritance. Okay, now interface can extend any interfaces. Okay, you can see the difference, like class can extend a single class, but class can implement multiple interfaces, and interface also can implement multiple interfaces. So I hope this is clear. Now after covering all the points, okay, by showing the code example at this point of time, I hope that every point is clear with you all, because this is the base concept when you go with the solid principles, or we'll be covering all the design patterns in the system design, low level design. So this is the base, and I hope this is clear. Now we'll be moving to the open close principle example. Okay, so now let's see the example of open close principle with the help of code. So what I have done here is I have taken one example which is not following the open close principle, and I have taken one more example which is following open close principle. Let's see the difference and what actually open close principle trying to show. Okay, so let's revise the definition that a class should be open for extension but closed for modification. Now we'll see that there is one class which I have declared named area calculator, and inside that there is a method which is known as calculate area. Okay, inside that I am passing an object which will in runtime find that if the object is an instance of rectangle, then calculate the area as rectangle length into width. If the object is the instance of square, then what we are doing, we are calculating the side of the square. Okay, so this is returning area as 0. Okay, so now let's uncomment something and we'll test what it is doing. Okay, so I have uncommented and we'll test that whether this is, if it is not following the open close principle and we have some new requirement, then how it is working. So for now what I have done here is I have created one rectangle class, created one square class. Okay, which I have okay, so now before that I'll tell you that there is a rectangle class which is having length and width, and the the constructor which is assigning the length and width. Okay, same as the square which is having side, and it is assigning the side with the help of constructor. Okay, so what I have done here is I have created a rectangle object, created a square object, and passed length and width in the rectangle and passed the side of the square. Now I want to calculate the area of the area of rectangle and area of square. So what I have done, area of calculator, this class object I have built. Okay, so I have declared a class object, and inside that I am calling the method calculate area. So in the calculate area, once I am passing the rectangle object and once I am passing the square object, what it is doing, so the object at the runtime it will find that it is an instance of rectangle, so it will calculate the area of the rectangle, and in this block if it is the instance of square, then it will calculate the side of the square. Okay, and finally I am printing the rectangle area and square area. Let's run this. This I'll save and I'll run. You'll see 5 into 10 is 50 and side square 10 into 10 is 100. So the area which we got is expected. Now if there is one more requirement came that I want to calculate the area of triangle, then what I have to do? Before that, just remember this definition: a class should be open for extension but closed for modification. It should be closed for modification. Let's say I have declared one more class of triangle. So I have declared base, height, and with the help of constructor I am assigning the base and height. Now this is so okay. We are creating a new class, that is fine. But inside the area calculator I need to do the change. So ideally it should be closed for modification, but for this case I need to do the change as else if an object is an instance of triangle, then calculate the area of the triangle. Okay, but you can observe one thing: whenever there is the new requirement, this is so fine, we can create the class, but the class, this should be closed for modification, but we have done the modification whenever new requirement comes, so it is breaking the open close principle, which is not following the open close principle. Now if we want, we can do it as we can give here triangle, and we'll be calculating the area of the triangle from here, triangle area, and we'll be printing the triangle area. Now if we'll run, you can see here we have printed the area of the triangle. Okay, so this way we can see that whenever the new requirements come, we always need to modify the existing class, which is not a good practice in terms of low level design. So now we'll see that the code which is actually following the same code which is actually following the open close principle, and how we are handling the new request whenever there is a new request came. Okay, so let's see. I'll comment this part which is not following the open close principle, and will uncomment this part which is actually following the open close principle. Okay, let me explain you what I'm doing here. So here what I have done, I have declared an interface. I hope you remember the interface and abstract, the difference which I have explained you. So in the interface, if you can see, this is the abstract method that I have declared. So now whatever class that implements this interface should give the implementation of calculate area. Okay, let's say this is class rectangle 1. So you can see that this rectangle is implementing the shape, and here is the instance variables, and with the help of constructor I am assigning the length and width of the rectangle, and implemented, we can also write here we can see here that calculate area, we have overwritten this method, means rectangle 1 has its own implementation of calculate area. Okay, similarly with the square 1, I have declared this side, with the help of constructor I am assigning this side, and I have given the implementation of calculate area, which is nothing but calculating the area of the square. Now so with the help of constructor I am assigning the radius variable and given the implementation to calculate the area of the circle. I have declared one rectangle which I am passing the length and width. I am declaring a square, passing the side. I am declaring a circle, passing the radius. Okay, I have created a list of shape where I am storing all the objects. Why the list of shape? If you can see, I have created a list of interface shape, like rectangle 1 is implementing shape, square 1 is implementing shape, circle 1 is implementing shape. So we can store all the classes inside this. So what I have done, rectangle 1 stored in the shape, square 1 stored in the list of shape, circle stored in the list of shape. Why? Because interface is shape, list of interface I have created. We can create the object of a class which is implementing the interface and store it in the reference of interface. The same thing which I have done here. Okay, I have created the object of the class which is implementing the interface and storing the class inside the reference of an interface. That I have done. Okay, and dynamically what I am doing, this shape S is coming. So first rectangle came, S dot calculate area, dynamically it will identify that okay, rectangle dot calculate area. So it will go and fetch this method, implementation of rectangle, which I have overridden or which I have implemented with the interface, like which I have given the implementation of the abstract method from the interface. So same thing it is doing. So let's say okay, so I'll run this and we'll see the output. So if you'll see, area is 50, first rectangle area is 50, area is 100, square area is 100, and area of circle is 7 pi r square, which is. Now let's say one new requirement came. then how are we handling this? Okay, so let's say we want to calculate the area of the triangle. So as you can see here, it is not following the open close principle. So again and again, when there is new requirements came, we need to change the class, which is not a good practice. If you again refer this definition, a class should be open for extension but closed for modification. Okay, now let's say how are we handling this for following open close principle. What I'll do, I'll simply create a class. So I have simply created a class triangle, which is again implementing the shape. I'm assigning the base and height with the help of constructor, and I have overridden the method calculate area. Now what I'll be doing, this is an interface. I haven't touched anything. Okay, now what I'll be doing, I'll just create a triangle object, pass it in the list of shape, and finally I'm done with it. Okay, so again I'm repeating what I have done here. I have created a triangle class, given the implementation of calculate area, and our work is literally done. Like what I'm doing, I'm creating a triangle object, passing the base and height, adding it in the list of shape, and just our work is done. If you'll see, if I'll run this program, you can see our output that okay, area of rectangle is 50, area of square is 100, area of circle is 153, and area of triangle is 20. Okay, so this is that simple. Now whenever our new requirements come, how we'll be doing in case of the one which is following open close principle, what I'm doing here. So again, let's say there is new requirement come. So what I'll do, I'll just implement that class. Okay, and our work is done. Just simply I'll declare the variable, create an object of that class, pass it in the list, and our job is done. In this case, we are not modifying the existing class. We are just extending it and taking the leverage of this principle. Like, so in this case, what we are doing, we are just extending it and we are taking the leverage of this interface instead of modifying the class every time, which we are doing in case where we are not following the open close principle or we are declaring the class. So I hope this is clear. So now we'll be moving to the third principle of the solid principle, which will be recording soon. Now we'll see what is composition and how it is different from inheritance. This is a simple notes that I have prepared. A one go of this simple notes will make you clear all the things about composition. I must say that you all know about this inheritance. Copying behavior automatically means if let's say there is a class A, class B extends A, then it automatically copy all the behavior of A. Composition is plugging behavior as needed. It means that you are having more control. Like it's not like blindly copying all the behavior from the parent. It's like whatever behavior you want, you can plug it according to your need. Now let's see. This is the inheritance. It means that take everything from the parent. When we extend, we'll get the methods, we'll get the properties, we'll get the behavior, but we also get things we don't want. Like there is a tight connection with parent. Okay, limitations on changing the behavior. So now why using composition? Use only what I need. So I have given an example. So class car engine is equal to new engine. In the class car, instead of extending engine, what I have done here is I have declared an object of engine and use it with our own need. So now we choose which objects to choose, how to use them, and when to replace them. Now question is, why do we need composition when inheritance already exists? So the answer, because inheritance is all. If either you can take all or nothing, it means that 1 or 0. Okay, composition is pick what you want. Okay, so now let's see the example of inheritance. Okay, so I have declared a class which is bird. I have declared a method which is void fly. Now I have declared another class which is penguin, which extends bird. The problem occurs here. Penguin inherits fly, but penguin cannot fly. This is a classical inheritance trap. As soon as I extend this bird, it means that all the features of the bird will inherit to the penguin, but penguin cannot fly. This is just a classical inheritance trap. Now with the help of composition, how are we solving this? I have declared an interface fly behavior. Okay, and inside that I have declared a method fly. So now I am declaring a class can fly, which implements fly behavior, where I'm giving the implementation of fly. It is a class can fly. So can fly, I have declared it as flying. Now class cannot fly implements fly behavior. Same interface I am implementing, and I have given the implementation as cannot fly. Now class penguin, same as what we are doing in inheritance. Instead of extending it, what we are doing here, I have declared a simple class penguin, and what I am doing, fly behavior is equals to new cannot fly. Why I am able to declare a class inside an interface? So the thing is, you can create an object of a class which is implementing this interface and store it in the reference of an interface. Again, I am repeating this definition. So you can create an object of a class which is implementing an interface and store it in the reference of an interface. The same thing which I am doing. I can create a class, I can create an object of a class class which is implementing an interface and store it in the reference of an interface. New cannot fly. It means that dynamically we can see that new cannot fly, which means this method cannot fly means this. Dynamically it will fetch the fly as cannot fly. Now inheritance relationship is a relationship. Penguin is a bird, okay, but penguin has fly, not okay. Composition has a relationship, means penguin has a flying behavior. We can choose the right one. Here is the difference. So means penguin has the flying behavior, okay, but we can choose it dynamically the right one. But for this case, in the case of inheritance, we can see here as soon as we extend bird, it will give all the property to the penguin. So I hope this is clear, like what is composition, how we can use it. Here also I can show you. I have shown with an example that class car which I have declared, instead of extending it, I am declaring the parent class, and dynamically I can change this and use the correct method or correct object. I have created a penguin class. Instead of implementing the fly behavior, what I am doing here, I have created a fly behavior interface object, and inside that I can dynamically choose the method which one to call. So I hope this composition is also clear, and open close principle is also clear. With the help of code example I have shown you, and I hope I am able to explain you in a better way or make it easy. Okay, so we have covered SO. Next we'll be seeing the L, which is nothing but Liskov principle. So thank you for watching and having patience. Okay, so now we'll be looking into the third abbreviation of the solid principle, which is nothing but the Liskov substitution principle. And in my point of view, I believe that this is the most important principle among all the solid principles. Okay, so just listen very carefully. I'll be starting with the definitions, going deep into the definitions, learning and explaining each and every line and each and every word of this definitions, and what this principle trying to convey to us. Okay, what's the use of this, why it exists, and I'll be explaining with the help of code examples also, and with some point of concept. Okay, so just listen very carefully and bear with me till the end, so that it will be very careful. And I bet that after listening to this, you don't need to refer to any other video or any other thing. Okay, this notes is enough and this video is enough to understand the Liskov substitution. So let's read the definition. So if S is a subtype of T, then objects of type T should be replaceable with objects of type S without breaking the program. I know that this must be little confusing. Let's read the definition once again, and then we'll directly jump into the explanation. Okay, so if S is a subtype of T, then objects of type T should be replaceable with objects of type S, okay, without breaking the program. Okay, so now let's see the explanation. Okay, then again I'll be coming to the above definition. So let's see. So what above I said is, if S is a subtype of T, okay, it means that S either inherits from or implements T. So why inherits or implements? Because T can either be class or either be interface. Okay, so S can either inherit or implement T. Okay, so if S is a subtype of T, that means S claim I am a kind of T. Okay, I hope this line is clear. This is nothing but the chunks of this above definition, this and this. Okay, so by declaring S as a subtype, we are making a promise. Okay, so by declaring S as a subtype, we are making a promise that anywhere T is expected, S can be used. Okay, till here I hope a very few things will be cleared, but it will slowly be getting cleared. So anywhere T is expected, S can be used. Now let's move further. Objects of type T refers. What objects of type T refers in the definition? So let's read the definitions one more time. That if S is a subtype of T, this I have explained, then objects of type T. Okay, let's see this. So here objects of type T. Objects of type T can be any variables, can be any parameters, can be any field, can be any return type. Okay, for this case we are referring to the parameters. Okay, so let's see what object of type T here we are referring. So T object. Okay, so this is the method where we are passing the parameters type T. Okay, so now objects of type T is also clear. Let's move to the third part of the definition. Let's go above and again read the definition. If S is a subtype of T, then objects of type T, okay, should be replaceable with objects of type S. Let's go down. So the third part is should be replaceable with object of type S. What this trying to say? The code is written knowing only T, not S. So now we must be able to do this without changing the code. It is saying that it should be replaceable with object of type S. Now I have created an object of type T, okay, or we can say that say T is an interface. I have created an interface reference which is pointing to an object of type S. Okay, this is a runtime polymorphism. Let's again read from the top. If S is a subtype of T, it means that S inherit from or implements T. So So S claims that I am kind of a T. Okay. Now by declaring S as a subtype, we are making promise that anywhere T is expected, anywhere in the method T is expected, S can be used. Okay. Objects of type T refers that it can be a variable, it can be a parameter, it can be a field, it can be a return type, but here we are referring to the parameter. Now should be replaceable with object of type S. Here we need object of type T, but it should be replaceable with object of type S. This just because of runtime polymorphism. With the help of a reference, this is the interface reference which is pointing to an object of type S, so we can directly pass this object inside this T, okay, which is nothing but an object of type S. Okay, I hope this is clear. Again, I'm explaining because this is very important. So if S is a subtype of T, that means that S inherits or implements. S claims that I am a kind of T. By implementing S as a subtype, we are making a promise that anywhere T is expected, S can be used. So what we are doing here, dynamically or runtime, with the help of runtime polymorphism, this reference of T is pointing to an object of S, and the object we are passing inside this method. So it should be replaceable with object of type S. Okay, object of type T should be replaceable with object of type S. Object of type T or object of type T should be replaceable with object of type S. Okay, I hope this is clear. Just because of this, we have eliminated the if object is an instance of S. So if this is not the case, if we are unable to do this, then every time we are passing the object inside this process, then we have to make a check that if the object is an instance of S. If yes, then we need to handle it. We need to do a special handling. So we have eliminated two things, that this we don't need to perform, this we don't need to perform. Why? Because here we can perform substitution of any of the subtype of type T can be used here. So I hope this is getting a bit clear. Okay, let me explain it one more time. So if S is a subtype of T, then it means that S inherits from or implements T. Okay, S claims that I am kind of a T. By declaring S as a subtype, we are making a promise that anywhere T is expected, S can be used. Anywhere T is expected, S can be used. Now this is the first S. Okay, there can be more, like A which implements T, B which implements T, C which implements T. So we can use any of the object which implements T, and just because we have created a reference of the interface T, we can point to any object which is implementing or extending T. I hope this is clear. This is nothing but the OOPS concept. Okay, let me explain you this OOPS concept. A reference of type T can point to any object whose class is T or any subtype of T. Let me explain with the example. So a reference of type T means A reference of type T can point to any object whose class is T. Okay, whose class is T. This is an object whose class itself is T. Object whose class is T, or any subtype of T. This is the object whose subtype is T. Any object S which is any subtype of T. Here we can see S is a subtype of T, so that we can use. So now again coming to the definition, a reference of type T can point to an object whose class is T or any subtype of T. Okay, same what I have explained here. A reference of type T can point to any object whose class is T or it is a subtype of T. For in this case, this is a subtype of T, as we can see here, because S inherits from or implements T. Okay, so I hope this is clear. Now let's again come back to the definition. If S is a subtype of T, extends or implements T, then object of type T in the method, if you remember that in the process method we are passing T. Okay, then object of type T should be replaceable with object of type S. Okay, T. So T obj is equal to new S object can be passed to T. So with objects of type S without breaking the program. So let's move further. Easy way. If a class B extends A, then B must behave like A. This is the one shot going definition. Now why LSP exists? Because let's say in the process, okay, let me explain you one thing. In the process, let's say I have T. This is the some code. So let's say T1 is equals to new something S. T2 is equals to new C. Okay, before the exist of this LSP, what we used to do is we pass T inside T and we put a special check that if T1, the object which we have passed, T1 is an instance of subclass. Okay, let's say S. T1 is an instance of some subclass, then there is a special handling. T2 is an instance of some subclass, then there is another separate handling. T3 is an object of some or an instance of some subclass, then there is again a separate handling. So we don't want that. That's why this Liskov substitution principle came into picture, that class B extends A, then B must behave like A. That's why we have eliminated this. Now this is the just simple definition that LSP exists to ensure that polymorphism actually works. Inheritance does not introduce bugs, and the code remain open for extension and closed for modification, which I have explained just before this principle. Okay, you can watch. If we break LSP, then inheritance is fake and abstract is lying. Now moving further, a class must be able to do everything the parent promised to do. Let's say class A is the parent and B is the child. So A has promised to do A1 task, A has promised to do A2 task, then the child B must also obey this promise. Okay, B also perform this A1, B also perform this A2, but it never refuse something that parent allows. Let's say parent allows A, parent allowed B, so it should also allow A and B. It should not refuse that. It should not refuse the functionality of its parent. Okay, and should also not throw any unexpected exceptions. So there is the core misunderstanding about this principle. Again, we are going much more deeper. So let's see. Substitution happens at a reference level, not at a class level. This will also be getting clear. Let's move to second point. LSP is never about replacing classes. It's about replacing objects behind a parent reference. Just now I have explained you that this one T is equals to new something. T is equals to new something. So it's about replacing objects. It's about replacing objects behind a parent reference. I hope this is clear. Now let's move further. Look at this line very carefully that we are dealing with a payment method PM. Let's say this is an interface which I have declared. Okay. Now this is the parent. Okay. Payment method PM. It means that PM behaves like payment method no matter what object it holds. Let's say it holds new A, then also it behaves like payment method. It holds new B, then also it should behave like parent method. So it is saying that it means PM behaves like parent method no matter what object it holds. Let's move to next point. Now look at this. PM is equal to new credit card payment. Okay, parent reference is still payment method. Child object is card payment. Now replace it. PM is still parent reference, which is payment method. New UPI payment. It is the child object means UPI payment. We replaced what parent reference points to. This is the parent reference. This is the parent reference. This is it is pointing to. This is it is pointing to. We are just changing the parent reference what it is pointing to. Okay, that is parent substitution, not the sibling substitution. Okay, we must have thought that we are only like substituting the child class. Okay, let's say credit card implements PM, UPI payment implements again PM. So we are substituting the child classes. No, it's not the case. So the correct way to say that is PM, which is the reference type of parent, is pointing to the object. So we replaced what parent reference points to. We replace what parent's reference points to. So this is the parent substitution. After that, the client could only see this payment method PM. It does not know or care which class or subclass is inside it. Is equals to whatever subclass is inside it. I don't care, or the client don't care. Client only knows that whatever class it holds, it should behave as a payment method. From the client's perspective, I'm working with the payment method as what I've told. So whenever we do complete payment, I'm passing the payment method and passing the amount. Okay, so the parent contract is being exercised. Why? Because let's say this is the payment method. Let's say I have created it as an interface, and inside this it is referring to some of the object. Okay, so the payment method PM, if I'm passing PM, so this contract is being exercised, means payment method is being exercised. Whatever method that I have written inside the payment method, or whatever method which I have declared, that method will be exercised here. Don't worry, I'll be explaining it with the code. So now let's move to the next point, which is LSP in one precise sentence. Okay, any object of a subclass must be usable whenever an object of the parent type T is expected. Okay, let's see. All the things which I have explained convey the same thing, just the another way of representing. So any object of subclass object, let's say there is S, let's say there is A, let's say there is B. So it is saying that, let's say some method it is expecting T. So any object of subclass, let's say S, let's say A, let's say B, must be usable whenever an object of the parent type is expected. Here object of parent type is expected, so any object of subclass can be used. I hope this is clear. So now what LSP is not saying, okay, the misunderstanding which I'm clearing around. Replace parent class with child class in code. This is not what LSP is trying to say. Change class definition. No. Swap one subclass with another directly. No. But on the other hand, instead what LSP is saying that whenever a program expects a payment method which is the parent, you may pass any of its subclass and the program must continue to behave correctly. Okay, that's correct. Now mathematically what I'm trying to say is, let's say this is the payment method which is nothing but a set of PE. This this credit card payment, UPI payment belongs to P. Now, then any function F, payment method P must work for every element of P. Means this payment method P can take either UPI payment, can take either credit card payment, can take either anything which is a subtype of payment method. So now final summary, we are not replacing one subclass with another. Okay, so as I have told, let's say PM is equals to new A, PM is equals to new B. So we are not replacing the subclass. Okay, instead what we are doing is we are replacing the concrete object behind a parent reference. Okay, this is the correct way to say. In any of the interview, if you are saying that the parent reference payment PM, we are replacing the concrete object. We are replacing the concrete object behind a parent reference. This is the parent reference which is pointing to S. This is the parent reference which can point to any object which is a subtype of PM. Okay, payment method. Or we can say that the parent reference can point to any object which is either a class or is a subtype of the parent. Now the parent stays constant, only the implementation changes. Now it's time to move to the code, because I have explained you each and every point, and that too in very detail, with explaining the OOPS concept and whatever the definition tries to say here. Okay, so let's move to the code. Okay, so this is T. Now inside this I have declared one method which is pay, which is basically taking the amount. Now this is S. Okay, S, which is a subtype of online payment method. If S is a subtype of T, S inherits from or implements T. Okay, S inherits or implements T. Let me write overridden the method according to this. Okay, now this again, this is A implements. Now net banking payment, again one subclass. C implements. Now again one method. D implements T. Okay, so let's see. I've declared one class. Inside that I have created one method which is complete payment, which is taking the parent. Okay, just this part will be exercised. By declaring S as a subtype, we are making a promise that anywhere T is expected, anywhere T, which is nothing but online payment, anywhere online payment is expected, we can replace with object of type S. Okay, we can replace with object of type S. So let's see. Inside the main class, what I have done here is online payment method dot payment one. Online payment method का payment one is equals to new object. Okay, this is the runtime polymorphism. So I have created the credit card payment, I have created the UPI payment, I have created the net banking payment, I have created the cash on delivery payment. Okay, now we can say that checkout service, which is nothing but online checkout service dot complete payment. Inside that I'm passing payment one. Payment one means dynamically or runtime it is complete payment is taking the parent. Okay, but we have passed payment one, which is nothing but credit card payment one, which is nothing but S. Now payment 2, which is nothing but UPI payment. A. Payment 3, which is nothing but net banking payment. C. Payment 4, which is nothing but cash on delivery. But here we are expecting parent, but we are passing the any subtype, which is, so we are passing the object of S which is implementing the parent. Okay, so now let's see, there is one failure which we are going to handle. Okay, so let's run the program and let's see what is happening here. A Java application, complete payment 1, inside that credit card payment. Okay, so credit card payment, where is credit card payment? Okay, so paid amount which is nothing but 100 using credit card. Okay, this executed successfully. Now second we have passed 50, which is nothing but UPI payment. Inside the UPI payment, paid amount which is 50 using the UPI payment. This also executed successfully. Now complete payment 3, which is 200 net banking, paid amount using net banking, which is also executed successfully. Now I want to uncomment this line and comment these lines just for the clarity. Now if I'll run this, it is giving that cash on delivery cannot pay online. Why this happens? So in the cash on delivery, if you'll see here, in the cash on delivery it is implementing online payment method, but cash on delivery we cannot implement this paid using net banking, paid using UPI payment, because still the payment is need to be paid. Okay, so I have overridden this method, but COD cannot pay now. So I'm throwing an unsupported operation exception that cash on delivery cannot pay online. So if you read this point carefully, must never throw any new unexpected exceptions. This is an unexpected exception that is throwing at the runtime. So we need to handle this. Okay, so for handling this, what I'm going to do is I'm going to create another interface. Okay, offline payment method. What it will take, void. Okay, so now in order to resolve that, what I have done here is I've created one more instance which is nothing but offline payment method, and for cash on delivery I'm implementing offline payment method. Okay, I'm overriding this method pay on delivery. Okay, pay on delivery. So for pay on delivery I'm taking the amount and payment of this amount will be collected on delivery. Okay, so I have created one more class offline checkout service. Why? Because taking the offline payment method. So whatever object that is the subtype of this can be passed here. So cash on delivery is, so this reference is taking an object of cash on delivery, so we can pass the payment for inside the offline checkout service dot confirm order, offline checkout service dot confirm order, the payment for. Okay, for the rest of the payment 1, 2 and 3, because this complete payment online checkout service dot complete payment is taking online payment method, so whatever online payment method we have, we can pass here. Okay, just like credit card payment, UPI payment and net banking payment. So these three will be handled with online payment method. This can be handled with offline payment method. Okay, so let's run the program, and now we can see we have handled it very gracefully, that paid using credit card, paid using UPI payment, paid using net banking, and the last one will be collected cash on delivery. So I hope this is the main part of the Liskov substitution principle. Okay, again I'm repeating, it is saying that parent reference can point to an object of any class which is a subtype of this class, okay, or interface. Just because credit card payment implements online payment method, UPI payment online payment method, net banking payment online payment method, so we can store it in the reference of this online payment method. And offline payment method, just because the cash on delivery implements offline payment method, so offline payment method reference to cash on delivery. Okay, and dynamically we can pass the payment 1, payment 2, payment 3 inside this complete payment. Why? Because this is expecting the parent payment method, and just because parent method, just because of this definition which is saying that objects of type T, means wherever objects of type T is expected should be replaceable with object of type S, should be replaceable with object of type S. Okay, these objects. Okay, so I hope this is getting cleared. I hope the definition is clear. I hope why we use LSP is clear, why it exists is clear, what way we used to handle without LSP is also clear, or the misunderstanding and some of the preconceived notions is also clear. What LSP is trying to convict is clear. So thank you for watching and having patience. I hope I am able to explain this topic well. So